Hello everyone, welcome back to another video here on this channel. Thank you for 10 subs already. Thanks so much. And as promised, we're going to do a BMO2 video. This is 2016, problem 4, so it's the last problem. So it's going to be especially hard. Anyway, subscribe, and at 25 subs, we'll do an IMO problem. Suppose that p is a prime number and there are different positive integers u and v, such that p squared is the mean of u squared and v squared. Prove that 2p minus u minus v is a square or twice a square. Okay, so first of all, without loss of generality, let u be greater than v. Second of all, we're going to think about 2p minus u minus v, and just think, okay, well, what if we apply some difference of two squares action here? Now, this may seem a bit random and unmotivated, but the reason why will become clear quite soon. Because when you do this, p squared is the mean of u squared and v squared. So p squared equals to u squared plus v squared over 2. 4p squared is therefore 2u squared plus 2v squared. And if we do this, then we get u squared minus 2uv plus v squared equals to u minus v squared. So this is pretty exciting because we've linked 2p minus u minus v to u minus v squared. So 2p minus u minus v times 2p plus u plus v equals to u minus v squared. Okay. And now, what we're going to be thinking about is the shared prime factors, because because it's a square, all the powers of everything are a multiple of 2. And basically, if a prime factor is not shared, then all of these will go to one or the other, and so each of these things is gonna be a square. But if there's a prime factor which is shared between the two, then that will take one factor each, and that will split up the even power into two odd powers or something like that. So that's the only way they're not gonna be square numbers. So we're going to let q be a prime. Let q be a prime, so that q divides both of these things. And by the way, this notation just means that 2p minus u minus v is a multiple of q. And q divides 2p plus u plus v. Now, because both of these are multiples of q, we can take the difference and get q divides... Actually, we don't have to take the difference. We can just take the sum, actually. Q divides 4p. Now, either q is 2, or q is not 2, and so q divides 4, or q divides p, because we said q was a prime. This is not true, so q divides p, and the only prime which is a factor of p is p, so q equals to p. And I guess with that, we have p divides 2p minus u minus 3, so p divides u minus 3, or I guess u plus 3, and p also divides u minus v squared from up here, and so p divides u minus 3 because the primes are still the same. And so I guess P divides 2V if you take the difference of these two. And because P, as we said here, P is not 2, so P is a factor of V. Now, the thing is, in this original condition, P is in the middle of U and V. So we have U is greater than P, which is greater than V. But V is at least P. So this is a contradiction. So this cannot happen. Which means the only shared prime factor is 2. And if the only shared prime factors are 2, then all the other factors are going to have even powers. Which means that either the only shared prime factor is 2 and it's 2 times the square. So if shared prime factor then it's 2, and so it's 2 to the n times p1 to alpha 1 p2 to alpha 2 or whatever. Now I guess I'll use like what should I use? I'll use like s. These are primes, and this is this is either a square or 2 times the square. Which is n greater than 1. Because if n is even, then it's a square, and if n is odd, then it's 2 times the square. But if there's no shared prime factor, then think of n as 0. If no shared prime factor, actually, we don't even have to say this because just shared prime factors always has to be 2. And if 2 is not shared, then I guess n is just 0. If no power of 2. But okay, the point is that u minus 3 squared has loads of even factors, and the only way to make them odd is if they're shared. So all the other powers of prime factors are even. So so the power of 2 has the only possibility for it to be odd, and if it's not odd, then it's a square number. So if n is even, 2p minus u minus 3 is square. And if n is odd, then it is 2 times the square. And so we're done. I guess we'll put like the square thing and shade it in. So this is the proof. It's not written up very well, but hope you understand, and hope you drop a like and subscribe if you enjoyed. I'll see you in the next one.